now have a closer look at equivalence. First of all, we can define equivalence between two logical expressions or two truth values p and q directly. Because there are only two truth values, true and false, we can define the value of p equivalent q. We can define the value of p equivalent to q for each combination of p and q. This is called a truth table. So if you look at this truth table, you see that if p is true and q is true, then they have the same value. So p equivalent to q is true. And if p is false and q is false, then they also have the same value. Both are false. So then the equivalence is true. And in the case then one is true and the other is false, then the equivalence is false. Now the equivalence, the truth table defines, now the truth table does define the value of an equivalence for each possible combination, but it's cumbersome to use in practice, in particular if you have variables involved. So therefore, we often use basic algebraic rules to manipulate logical expressions with equivalence. As you can see here, the most important rules here. So if you compare algebraic expressions and logical expressions, you find out that equality is reflexive, A equals A, it's symmetric, if A equals B, then B equals A, and transitive, if A equals B and B equals C, then A equals C. And because equivalence is just equality between truth values, then we have the same property. For any logical expressions, PQ, then we have that P is equivalent to P, and if P is equivalent to Q, then Q is equivalent to P, and transitivity, if P is equivalent to Q and Q is equivalent to R, then P is equivalent to R. And besides these, we have the general rules for functions, that if A equals B, then f of A equals f of B. And the same holds for functions from real values to truth values, called predicates. If A equals B, then P of A equals P of B, where P is some relation which contains A or B.